Good evening. Can you hear me?
Yes, sir.
Good. Last week, what we discussed? We discussed mass measuring instruments, right? Uh, Before last week, we completed length measuring instrument. What we discussed under length measuring instrument? 4 instruments we discussed. What are they? Meter ruler, vernier caliper, micrometer screw gauge, and traveling microscope, right? Okay, last week we discussed about triple beam balance and electronic balance also, right? Shiva?
Yes, sir.
Oh, only triple beam balance.
Only triple way imbalance, sir.
Yeah. Okay, today our lesson is electronic balance and stopwatch. Okay, today that's the final part of the measurement lesson. After 30 to 40 minutes, we can complete the lesson, and you have a tutorial. I hope you complete that. Are you work on this tutorial? Right hand? Complete. Jansilu? Very complete. Okay, this one. Tutorial. Yeah, this one. If you want, you can get print out. If you want, I can send this as your next tune. If you want, I'll send it. Okay, I have already printed papers for physical students. I will send you. I'll post you. If not, you can take a printout. It's only 2 pages. It's only 2 pages. Okay, I'm done. Is it complete? Asil?
Yes, sir.
Akil? Okay. First, let's move into the lesson and complete the lesson first. After that, we can discuss. It is very simple. Some questions are past paper questions, past exam questions. We have everything discussed. Everything we have discussed in the class. Come to the lesson first. Then on, we discussed up to this point, no? Up to the zero error of triple beam balance, right? හරි the electronic balance පටන් ගත්තේ නැහැ. Correct, right? Yeah, good. Okay, our second mass measuring instrument is the electronic balance. Actually, it is very simple. It's very simple. Why it is very simple? Because triple beam balance, you need detailed knowledge, right? Detailed knowledge, how to read measurements and how to check the zero errors, and you can adjust by what is this note? You can adjust by tear adjustment. You can adjust and clean the measuring pan and place the object on the measuring pan, and starting from heaviest mass, and it is moving, and next heaviest mass, the smallest mass, moving until indicator coincide with 0 point. It's a huge process, and you should have some technical knowledge. The person who obtain measurement, he or she should have technical knowledge, right? A technical knowledge actually anyone can't get accurate readings using triple beam balance. But the advantage, when we use electronic balance, what is the advantage? We don't need any advanced calculation or advanced methods. Just keep object on the measuring pan, we can get the measurement on the digital screen. Okay, what do you think the not zero error, least count of this instrument? What's the minimum reading that we can obtain by this instrument? What do you think? Approximate value? What is the least count? Digit may electronic balance. Least count. Mm, 0.1 gram. 0.1 gram in triple beam balance. Yeah, triple beam balance is correct. I'm asking about electronic balance. Hashim. Actually, yeah, your all answers correct. Actually, we can't define a specific value for least count of electronic balance. What's the reason? We can't define specific value. What's the reason? Sometimes these electronic balance are very sensitive. Very sensitive. As example, do you know analytical balance? Do you know analytical balance? Analytical balance. Raise hand if you have seen this. Analytical balance. It's a type of electronic balance electronic scale that we use in laboratory purposes. How you can identify analytical balance? It is covered by a glass plate, glass box. I'll show you. Analytical balance. Analytical balance. Tomorrow is the final day for your practicals, no? Am I correct? Tomorrow, day after tomorrow. Your O-level practicals? I think tomorrow, right? Hari අපි හිතමු tomorrow mean 4 or 5. 4th or 5th of May is the final day, I think. Okay, if it is 5th is the final day within 3 weeks. No, after 3 weeks. After 3 weeks mean 5th is the final day. 5th plus 21 days. It is 26 days. Okay. Final week of this month, you will have result. Normally that's if there are no any technical or whatever problem, 3 weeks වලින් එනවා. 3 weeks වලින් පස්සේ ඊළඟ week එකේ එනවා results. එතකොට final week එකේ එනවා මේ මාස. Okay, they are the analytical balance. Do you have seen? They are the analytical balance. It is full, the measuring pan fully covered with glass box. Fully covered with glass box. See? Okay, can anyone they are the parts. This is a glass door and this is a balance pan, that means measuring pan, and this is a door handle and this is a display, and there is a tear button also there. There are level adjustments and other buttons, power button and mode buttons. Okay, they are the main parts of the analytical balance. Okay, my question is why it is covered with glass box? Why it is covered? ඇයි වහලා තියෙන්නේ? ඇයි ඒක වහලා තියෙන්නේ? What's the purpose? Covering. No, not prevent particle, not prevent dust particle. No, that's not the reason. Yeah, you are correct that we use in laboratory purposes. Laboratory purposes වලට තමයි use කරන්නේ. We measure powers of powders. Shiva. Powders. No, powders, it's not compulsory to in a closed container. What's the purpose? Actually, it has a reason. What do you think? A kill? Think. Very good. Xenon correct. No, dust is not the reason, Nithya. To get highly sensitive measurement. Yeah. Then අපි මේක close කරේ නැත්තම් මොකද වෙන්නේ කියලා මං අහන්නේ. If it is not closed by glass box, what's the problem coming? ඒක හොයාගත්තා නම් හරිනේ. What's the problem coming if it is not covered? Yes, environment disturbances. Yes, that's the reason. Okay, no, normally I think in grade 5 to 6, no, I think grade 6 or 7. Also, you doing science practical, you measure, I think you're doing this practical in grade primary classes, right? First, you can measure empty balloon ball. Then balloon ball full with gas and measure. Then what happened? You can find the weight atmosphere, air also, gas also contains some weight, right? Gas also has mass into gravitational acceleration. It has a weight, and however mass. The atmosphere gas also contains some mass. Okay, in this analytical balance, we used to get more sensitive, more precise measurements. Very small quantity of chemicals. Very, very small quantities. Sometimes 0.001 grams. Therefore, if it is keep open, this atmosphere disturbance, that means air mass of the atmosphere, air gases effect on this measuring pad. That's why we need to make sure take this sensitive measurement in a closed container without atmosphere disturbance. I got without atmosphere disturbance. Then ඇත්තටම මේකේ we can remove this glass cover. And if it is kept in normal atmosphere, make open කරලා තිබ්බම we can see the value vary without any object on measuring pan. This value vary. What's the reason? The air mass also affect on this measuring pan. That much sensitive this instrument. This instrument is very, very sensitive. That's the reason. Normally, supermarket or whatever instrument made electronic balance, we're not going to cover. Because that atmosphere effect we can neglect. But this type sensitive measurements, the atmosphere mass also affected. Right? Understood? Okay, that's why it is covered. It is covered by glass plate. Understood? Vihanga? Right. Okay, actually, due to these reasons, it's a huge range of electronic balance, right? අපි ගමු තව එකක්. Do you know bridge scale? Now the analytical balance used to get very sensitive, very small measurements, right? Very small measurements, very small chemical quantities. But what's the purpose of bridge scale? Bridge scale දන්නවද? Bridge scale අපි කියන පාලන්තරාදි කියන bridge scale. Bridge scale. Bridge scale. දැකලා තියෙනවා? Bridge scale. You have seen bridge scale? Bridge scale. බලමු. They are the bridge scale. This one. Yeah, this is a bridge scale. Do you have seen? දැකලා තියෙනවා? Raise hand if you have seen. Okay, what's the purpose? Which type functions we use this bridge scale? To measure vehicles with loaded vehicles and empty vehicles, right? Empty vehicles. Actually, the purpose of this bridge scale, it's a full automated. It's full automated. You can see that's a digital screen. This is a digital screen, right? This is a digital screen and it has sensor and everything automated. Everything automated, and all sensors and digital screens connected into a computer system. It's full automated system. Full automated system. Okay, do you know what is the purpose of this bridge scale? Bridge scale, the purpose, get large measurements. Vehicles, sometimes it is we can measure 20, 50 tons as well. Normally the maximum, it is maximum, I think 100 tons. 100 tons is the maximum. That means 100,000 kilogram. 100,000 kilogram is the maximum weight. Okay, this is actual purpose. Now think this is a industry, whatever textile or garment or whatever industry, right? Sugar industry or whatever. Think it is an industry. It's an industry. Industrial zone, right? Industrial zone. Think it is a textile industry. Now textile means clothes and they are related industry, right? Right. Now think this is the entrance. Make a factory එකක් කියලා හිතමු. හරි. මේ factory එකේ this is the entrance. This is the entrance gate. Close to entrance gate, we can place bridge scale. This is a bridge scale. Right? This is a bridge scale. We can place a bridge scale at the entry. හරි. මොකද වෙන්නේ? Now think our requirement to keep records of daily or weekly or monthly the input, raw material input. අපි කියමු textile නම් raw textile input. හරිද? input amount එක තමයි අපිට ඕනේ. එතකොට okay, first we can measure vehicle එකේ input vehicle, that means with textile loaded input vehicle first come onto this bridge. Then we can get this mass of this vehicle using the it's a computer system. It is automatically recorded in the system, right? Then after that it's entered to the industry and unloaded. Now think this value, the vehicle weight with loaded vehicle, raw material loaded vehicle, 13 tons. 13 tons is the vehicle. Total weight, right? Total weight load plus vehicle weight, right? After unloading, the vehicle again coming to this bridge scale. I'm an empty vehicle come to this bridge scale. Then this empty vehicle mass also automatically recorded on this. Think it is 8 tons. Then this is system according to vehicle number. The system record this particular vehicle input 5 tons of textile. I got, okay, that's a purpose. That's a purpose. It is very easy to maintain records in factories and industries using a bridge scale. That one also electronic balance. Previously I told analytical balance also electronic balance. I got. Now you can understand the range. Analytical balance, electronic balance, that is used to get more very sensitive measurements. The atmosphere also is affect on these measurements. Therefore, we have to get these measurements in a closed container, separate container from the atmosphere, right? But if you got in large scale bridge scale, we can get more than 10 ton or 100 50 tons like measurements as well. I got the difference. We can, I just want to show you electronic balance nowadays due to the novel technologies. Electronic balance used in different field according to the different purposes. Yeah. Hub also use this one. Okay, I just want to show you the least count. Sometimes this analytical balance least count 0. Analytical balance least count it is 0.0001 gram, right? 0.001 gram. Sometimes with bridge scale least count, the minimum reading then api bridge scale එකට ගියාට value එකක් පෙන්නයිද? දැන් අපි normal අපි 50 to 60 kilogram පෙන්නයි. No any value showing. What's the reason? It's normally it is the least count like 100 kilogram වගේ තමයි තියෙන්නේ. The least count, the minimum reading of bridge scale. I got. Okay, that's the difference. Therefore, the least count of electronic balance, we can't say exact value that is changed according to the purpose of this balance. Different industries, different field, different types of technologies and mechanism used in electronic balance, and their least count also change according to this purpose. Understood? Jansidu, it's very simple, right? Hi. Other thing, the next thing, do we need to worry about the zero error of instrument, zero error of electronic balance? No need to worry. Why? This instrument has a tear button. See, this is a tear button. Using this tear button, if there are any changes without any object on measuring pan, if it is not showing zero value, we can press zero tear button and get again into zero reading. Therefore, no need to worry about zero error. Actually, this one instrument has zero error, but that we can correct by using tear button, and it's an advantage. The other thing, it is no need any technical knowledge. Anyone can get measurements, and it is more accurate than the triple beam balance. Okay, they are the advantage. Okay, that's the story. That's the electronic balance. Different types of electronic scales can be measured, very smallest measurements as well as very largest measurements. Okay, write down examples. Very small measurements. Very small measurement. Example, analytical balance. Analytical balance. So only one example, right? There are different types instrument as well. Analytical balance. Analytical balance. Very large measurements. Very large measurements. What's example? Bridge scale is one example. Bridge scale. Okay. Note down and complete your tutorial. Sweta, are you collect tute? Are you collect tutes? Now I think you all have tutes. For everyone I have posted. Sorry, your tute pack has late due to our system error. That was found after 1 week late. Okay. Okay, now you can explain advantage, right? It is very simple. Now anything to remember about electronic balance. What are the advantages of electronic balance than triple beam balance? We don't need any advanced technical knowledge. We don't need any advanced technical knowledge, and it is more accurate than triple beam balance. And different types instruments available in different industries, different field according to the purpose. That's an advantage. And what else? Easy to adjust zero error. We have a tear button. Okay, that's the end of electronic balance. Very simple. Okay, this is our final instrument, time measuring instrument. For time measurements, we use stopwatch. This is stopwatch, mainly two types. What are the types? Digital stopwatch and analog stopwatch. This is an analog stopwatch. This is a digital stopwatch. Okay, easily we can find a digital stopwatch. Your phone. Yeah, this is a digital stopwatch. Okay, this digital stopwatch, if I start, can you find the least count of this one? මේ value එක බලාගෙන හිටියොත් ඔයාලට පුළුවන්. What's the maximum value this right side? මේ speed change වෙන එකේ what's the maximum value? No, Shivan, not millisecond.
Hour.
Yeah, 99. Yeah, දැන් ඔයාලට මේකේ 99 පේනවද? හොඳට බලන්න. 99 වලින් තමයි again it's come to 0. Right? 99, then it is 0. Okay, actually this digital stopwatch 1 second 1 second divided into 100 identical parts. 99 mean 99 0, that means 100 identical parts. Good, Priyanka. 100 identical parts. It's very simple. It's not milliseconds. Don't misunderstand. 1 second divided into 100 identical parts. Is it 1 millisecond? No, it is not 1 millisecond. It is 0.01 second. Then what's the meaning of millisecond? Millisecond mean milli mean gram divided into 1000 milligram, right? Samely, milli is a prefixes. I think you can remember in the first page I explained milli mean 1 second. If you divide into 1000, it is 1 millisecond. Millisecond. Milli is a prefixes. It's always given for divide by 1000. Divide by 1000. It is not Shevan. It is not millisecond. I got milli is prefixes. Always milli prefixes given for 1000. Divide by 1000. අපි ගන්න මේ millimeters මතකයිද? Millimeters everything same. Millimeters 1 meter divided into 1000 identical parts, it is equal to 1 millimeter, right? මතකයිද? 1 meter divided into 100 identical parts, it is 1 centimeter. 1 meter divided into 1000 identical parts, 1 millimeter. Milli is a prefixes. It's always given the divide by 1000. Therefore, if we need to get 1 millisecond, 1 second need to be divided by 1000. 1000 වලින් divide කරාම තමයි milliseconds ඇති. Right? It is not millisecond. Okay, this is a digital stopwatch. Least count 0.01 second. That means 1 second we can divide into 100 identical parts and we can measure. Okay, what do you think about analog stopwatch? What's the least count? What's the least count? Analog stopwatch. Analog stopwatch. Analog. What do you think? Is it 1 second? Now you have two answers. 1 second or 0.1 second. Analog stopwatch. .1 second. Normally, to measure 1 second, we don't need a stopwatch. Vinuji, not 0.2. To measure 1 second, we can use normal clock. No, the stopwatch, we normal analog stopwatch, it's 0.1 second. That means 1 second divided into 10 identical parts. 10 identical parts, right? Okay. This digital stopwatch, actually it is very simple. No need to, now you already know. This digital stopwatch, you have another option. See, now it is start. And we have another option, laps. What's the meaning of that? Laps, first lap, second lap, third lap, fourth lap, fifth lap, sixth lap. What is the meaning of laps? What is the meaning of laps? Laps කියන්න මොනවද? What's the purpose of this lap button? And keep laps. Yes, one lap mean one round. Oh, me think marathon. Think about marathon competition. Think about marathon competition. This is a track. Right? Think this is a starting point and same point is a finishing point. Now, all starting from this point, all competitors starting from this point, at starting, I can reset and start, right? Starting. Okay. When first competitor complete, that means first පළවෙනියට ගන්න students complete කරද්දී I don't need to stop. If I stop, we can only measure first competitor, right? But we have to continue. Therefore, we can, without stop, I can give me a second. Yeah. Now think now start. Now think this is the first lap. Still the first lap is running. First lap එක තමයි run වෙන්නේ. හරිද? Now think one first completed, first student, first place is got student completing. Now I don't need to stop. If I stop, we can't again measure. Then if you need to continue and stop, we can press only lap. Then you can see first competitor consume time. It is recorded. It's recorded. First place consume time. Now think this is a second competitor finishing time. Then second lap. This is a second competitor finishing time, this green color one, right? Third one, fourth one, that we can continue. We can continue this without stopping. Okay, that's an additional advantage of digital stopwatch. Have you understood? Right. Nitira? Hi. Okay. The final point of stopwatch. Okay, now not like other instrument, this stopwatch, it is mainly affected human errors. Why? Now think to start or stop, that is completely depend on the human. That means the operate person. Now this time I'm the person operating this instrument. Now my reaction time, my thinking time, reaction time, mama hand එක අරගෙන මෙයා start කරන්න ඕනේ. That means it has some reaction time. It has some reaction time. This reaction time can be changed person to person. Therefore, it's possible to come in errors, human errors, personal errors of this instrument. Not like other measuring instrument, mass measuring instrument. They also come in human errors, but the stopwatch, it's greater. Why? It's mainly depend on the starting and finishing time, depend on the person reaction time. I got. No matter how sensitive this device is, measurement errors vary depend on the person measuring the start and end time of this action. Understood? That's depend on the operate person. That is, the reaction time of the observer also affect the measurement. The reaction time of the observer, thinking and reaction time, right? The following steps can be followed to minimize that. We can't stop this personal errors. We can completely minimize, but that we can minimize up to certain level following these steps. Okay, what are the steps? They are not asking, right? Just general things given. Start taking readings with advanced preparation. That means we can get full idea, full understand about the event, if it is whatever running competition or whatever other competition or whatever event, we can get the full idea. Then we can avoid personal errors, right? in a measuring instrument, measurements such as the period of oscillation of simple curve, first count down and turn the instrument turn on. That means we can keep some countdown, 3, 2, 1, on, like this. Then we can minimize reaction errors, no? Reaction time varies. We can prepare, right? We can prepare. They are simple things. If you understood, it's enough. To make readings for a greater number of oscillations, yes. Without taking only one reading, we can get several time, and we can confirm. We can get several times for same. If it is running competition, if you think you are going to get a number of oscillation or number of turns rotate within 1 minute, then we can get 1 minute time period and get a number of rotations. We can get another 1 minute and rotate, count the number of rotations. Again, if you want, you can get third time. If it is same, we can confirm, right? We can minimize errors. We can get several times. Before using the instrument, check that show 0 reading correctly. Yes, we have to reset this before use the instrument. If it is not 0 value, we can reset this. Okay, that's the end of instruments. That's the end of instruments. Okay, do you have any doubt? Now we can ask. We discussed about mass measuring instrument, length measuring instrument, and time measuring instruments as well. No doubts, right? Anyone? Viniji? Sweta? Akhil? Palindu? Xenon? Good. Okay. Okay, come to the final topic of measurement lesson, errors while taking measurements. Errors while reading measurements. Okay, actually in instrument errors, main instrument errors we discussed, 0 errors we discussed during instrument discussions. Now we are discussing actually these errors. It is very important to find suitable instruments. That means actually that's the story. I'll explain the full story. Okay, instrument errors mainly two types. The first one is a personal errors. Personal errors mean human errors. Person to person, this error value can be varied, right? Personal errors or human errors. Personal errors. And instrument errors. The 0 error type of a instrument error, right? Instrument errors. Instrument mean that's depend on the measuring instruments. Instrument errors. Okay, I told personal errors. That means human errors, person to person. The measurement taking person to person, this value can be changed. But instrument errors, there are different types. Instrument errors. 0 error is a one instrument error. 0 error. And there are other two errors that we discussing in the final part. fractional error and percentage error. 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 Right? Percentage error. Actually, this fractional error and percentage error we can use as a guidance, use as a guide to select suitable instrument. To select suitable instrument. Actually, this fractional error and percentage error both depend on the depend on the least count errors. Least count errors that mainly depend on the least count. Least count. The actual meaning, normally when we take measurement, if it is very close to the least count, as example, 0.1 milliliter is a vernier caliper reading. Vernier caliper least count, sorry, vernier caliper reading. Okay, if you use this vernier caliper to obtain 0.3 millimeter like measurement, I told it is not a suitable instrument for this reading. Why? These measurements very close to the least count. A close it is possible to coming errors. Possible to coming errors. Okay, that's actually fractional and percentage error represent the errors coming instrument due to. Give me a second. Sorry. Errors coming instrument due to the least count. Due to the least count. Due to the least count. Maybe. Okay, our first error type is fractional error. Fractional error. Fractional error. Okay, it's a very simple thing. Fractional error is the ratio between least count and the measurement. This measurement should be accurate measurement, right? Accurate measurement. Accurate measurements. Accurate measurement. Accurate measurement. Okay, that's the story. The least count over accurate measurement. Least count over accurate measurement. Fractional error. Our second one is the percentage error. Percentage error. Percentage error. This percentage error means fractional error fractional error into 100%. Into 100%. Very simple. Fractional error into 100%. What's the purpose of fractional error? To calculate the percentage error. Actually, our purpose to get the percentage error. Now I can say final equation percentage error equal least count over least count divided by accurate measurement into 100%. Okay, this is the equation. This is the equation. Practice least count over accurate measurement multiply by 100%. Okay, that is a percentage error equation. Percentage error equation. Percentage error equation. What's the equation? Least count over any instrument least count divided by accurate measurement multiply by 100%. Least count over accurate measurement multiplied by 100%. This is the equation of percentage error. Okay, what's the purpose of calculate this percentage error? This percentage error, as I told earlier, this percentage error we can use as a guidance. Guidance to select suitable measuring instrument. Right? This percentage error is a guidance to select suitable measuring instrument. To select suitable measuring instrument that we can use as a guidance. Guide the period. Okay, it's just like this. Very simple. Very simple. Make example again. Try to understand by this example. Very simple. Okay, I'm going to use vernier caliper. Vernier caliper to get 0.3 millimeter reading. What is the least count of vernier caliper? 0.1 millimeter. divide by accurate measurement 0.3 millimeter, right, into 100%. Can you get this value? Percentage error. What is this error? You can use calculators. What is this value? That means 0.1 multiplied by 100, it is 10 over 0.3. It is 33.33, right? 33.3%. It's a large value. It's a large value. Remember, no, Hashin, it 100%. Use calculators. Without, yeah, correct. Yeah, without 100%, it is 0.333. Good. Yeah, if you got percentage mark, it is 33.3%. Correct. 33.3%. I want percentage value. We need percentage value. That's why we called as percentage error. Right? Hari. මම මේක ටිකක් අපි ගමු 3 millimeter වගේ එකක් නැත්නම් අපිට understand කරන්න. 3 millimeter. The least count vernier caliper least count 0.1 millimeter. I'm going to get 3 millimeter or 3.2 වගේ එකක් 3.2 millimeter using this instrument. What's the least count? Not least count, may percentage error. What's new percentage error? I want percentage value. Three point 125%. 3.125%. Right? Okay, now actually the micrometer screw gauge, sorry, vernier caliper, this is our instrument vernier caliper in 0.1 millimeter I got. This vernier caliper, I can decide this vernier caliper not suitable to get this reading. 3.2 millimeter reading, vernier caliper not suitable. Vernier caliper is not suitable instrument. How we can decide? Hari, අපි මම එක පස්සේ කියන්න. Okay, think to get same measurement, if I use micrometers to gauge, what is it? Is count 0.01 millimeter divide by 3.2 least count of accurate measurements into 100%. Okay, what is the percentage error? What's the percentage error? this calculation. 0.1 into 100. Okay. 0.1 into 100, it is 10. 10 over 3.2, it is 3.125%. $0.315, right? 0.315, 0.315%. Okay, now I can decide the vernier caliper. According to this percentage error, vernier caliper is not suitable to get this reading. Vernier caliper is not suitable to get this reading. Micrometer screw gauge is a suitable instrument to get this reading. How I can decide? I told this percentage error we can use as a guidance to select suitable instrument. Then how we can decide? Remember, the normal recommended range is 0 to 1% is the recommended way. Remember, the percentage error, if it is greater than 1%, that we consider it's not suitable to get this particular reading. This instrument not suitable to get this particular reading. If it is less than 1%, is a recommended range. Recommended range. I got less than 1% is a recommended range. That's why it is less than 1%, 0.315. It is suitable. This micrometer screw gauge is suitable, but vernier caliper, it is greater than 1%, therefore it is not suitable. Understood? Akit? What happened? Sweta? So when I do it in the calculator, I don't get the correct answer. Why? Yeah, you have to use brackets. මෙහෙම කරන්න ඕනේ. 0.01 multiply by 100 brackets. After that, divide by 3 point. එහෙම කරලා බලන්න. 3125. Okay. Yes. Which part, Akhil? This calculation part or substitution part? Calculations. Make 0.1 multiply by 100. Use calculators. Use a calculator. 0.1 multiply by 100, it is 10. 10 divided by 3.2, it is 3.125 percentage. Okay, that's a percentage error for vernier caliper. If you use vernier caliper to get this reading, this is a percentage error. First one, okay. Okay. Same thing. 0.01 multiplied by 100, it is 1. 1 divided by 3.2, it is 0.3125%. The recommended percentage error range is 0 to 1. Therefore, if it is more than 1%, it is not, we consider it is not suitable instrument. Therefore, to get this reading, vernier caliper is not suitable by the percentage error greater than 1. But micrometer screw gauge, it's suitable by it is less than 1%. percentage error. Now, okay. Okay. Others? Any doubt? Pinuji? Okay, go to tute. Okay, these are fractional errors. Fractional errors, least count of the instrument divided by measured value. This measured value should be, remember, it is accurate. This value should be accurate. What's the meaning of accurate value? Accurate mean without zero errors. Without zero errors, remember. Accurate value mean without zero errors. I will explain in the tutorial. Without zero errors. Without zero errors. You can, if it is positive zero errors, before substitute this value, we have to subtract. If it is negative zero error එක add කරලා තමයි දාන්න ඕනේ. Without zero error. Without zero error. Without zero error. This is a percentage error. Least count divide by that one also accurate reading. Accurate mean without zero error, right? Without zero error. Accurate mean without zero error. Okay, the percentage error helps to determine whether a measuring instrument is suitable for particular measurement. Please highlight this. The percentage error helps to determine whether a measuring instrument is suitable for particular measurement. Okay, that's a purpose. That's a function of percentage error. If the percentage error is small, the measurement more accurate. Yeah. If the percentage error too small, the percentage measurement more accurate. If it is great value, the percentage not reliable, very less reliable. Remember, that's why we call the recommended way is 0 to 1%. If it is greater than 1%, we consider the instrument is not suitable. If the percentage error for a particular measurement exceed the 1%, the measuring instrument generally considered unsuitable for this particular measurement. Remember. Therefore, it is important to select measuring instrument with an appropriate least count to maintain percentage error less than 1%. Remember, this is a recommendation. This is a recommendation. Less than 1%, you have to maintain the percentage error while you select an instrument to get measurement. That's the end of measurement lesson. Your first lesson completed with all practicals. Okay, do you have any doubt about this percentage error? Now you can ask. Now 7:45, I am going to start our tutorial. We got 15 minutes than expected. No doubt, right? Akhil, Jan Silu, everyone understood? Okay. Okay. Please get your tutorial. Okay. Okay. Let's start question number 1. I got answers. So come complete. Akhil, I complete. Okay, let's see. The main scale of vernier caliper has 1 millimeter divisions. Okay. 9 main scale divisions coincide with 10 vernier divisions. What is the least count of this instrument? What's the least count of this instrument? Yes, it is very simple. Take a paper. Please find a separate paper. Oh, no problem. You have a notebook, right? You all have notebook. Write down measurement tutorial question number 1. Measurement tutorial. Oh, measurement tutorial question number 1. Now answer is 0.1 that you already know, but you should know the equation as well, the full idea. Okay, this is the equation. They are very important for final days, not now. When you're ready for the exam, this description is very important. Okay, question number 1. Okay, the question asks the least count of vernier caliper, right? The main scale of a vernier caliper has 1 millimeter divisions. 9 main scale divisions coincide with 10 vernier scale divisions. Okay, this is story. Okay, this is the main scale 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it is continue up to 150. I told 150 millimeter is a main scale final value. That means 15 centimeter. That's your normal ruler, right? The question given 9 millimeter on the main scale. This is a 9 millimeter. 9 millimeter on main scale divided into 10 identical parts, 10 identical divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 identical divisions in the vernier scale. It is 9 divided into 10 identical divisions. Yes. Now, do you remember in vernier caliper least count, we have a small equation. Least count of vernier caliper. What is the equation? Short term එකක් තියෙනවා නේද? MSD minus VSD. MSD minus, you have to remember them. MSD minus VSD. What's the meaning of MSD? Main scale division. Main scale division. One main scale division. What is a main scale division? This point to this point. 1 millimeter, right? 1 millimeter. Minus vernier scale division. Now 9 millimeter divided into 10 identical parts. කොහොමද කරේ අපි? 9 millimeter divided into 10 identical parts. How to get one vernier scale division? Then 9 divided into 9 millimeter divided into 10. Then we can get one identical part distance or one vernier scale division. Okay, 1 millimeter minus 0.9 millimeter. The answer 0.1 millimeter is the least count of this instrument. Okay, that's the equation and full answer. Okay, answer number 4. Answer number 4, 0.1 millimeter. Clear? Please note down these. They are very important. This equation is very important. MSD mean, if you can't remember, main scale division minus vernier scale division. Pigment and complete. Bihanka? Done. Question number 2. The same equation, right? The least count of vernier caliper 0.1 millimeter. Yes. If the length of main scale segment, that means MSD, 1 millimeter. What is the length of vernier scale segment? Same equation. Same equation. The least count of, I'm going to erase that. If you can remember this equation, least count is given 0.1 millimeter, right? Main scale division given 1 millimeter. And VSD is asking. Now you can isolate VSD. VSD get into this side plus VSD. 1 millimeter. 0.1 get into right side minus 0.1 millimeter. And VSD equal 0.9 millimeter. Answer number 3. Same equation. Akil, in doubt? Good. Okay. Vernier scale division equals 0.9 millimeter, right? Good. Okay. The scales of a vernier caliper is arranged as follows when taking a measurement. The instrument given reading will be, and 10 vernier divisions coincide with 9 millimeter on main scale. Okay, what's the hint given in this within bracket? Okay, මොකක්ද කියලා තියෙන්නේ? 10 vernier scale divisions coincide to 9 millimeter on main scale. What is given? Shiva, what is given here within bracket? What is this hint? ඒකේ මොකක්ද කියවෙන්නේ? The least count, very good. It's a hint about least count. Making all make a දැක්ක ගමන් you should know the least count of this instrument 0.1 millimeter. Great. 0.1 millimeter is the least count of this instrument. Now the question asks, what is the reading on this instrument? Hari. Send your answer. What is the reading? Mankaranda. Don't take time. What is this reading? What is this reading? Great, Shiva. Yansilu. Okay, do you remember steps? Xenon. What is this? A cell? Vihanger? No. No, Asay. Don't try to get answer in centimeters. First get answer in millimeter, read the measurement in millimeter, then finally you can convert into centimeter. That's the best method. If not, it's coming errors like I say. Akil, Nitira, Senura. No, say no. Try again, try again, try again. Savindya. No, what are the steps to read this measurement? What are the steps? What is the first step? Get the main scale reading. Okay, how to get the main scale reading? The value before vernier scale 0, right? This is the main scale 0. Oh, sorry. Battery low. Now correct, Asir. Okay. First step is the get main scale reading. What is the main scale reading? What's the main scale reading? 2 centimeters. I told always use millimeters. 2 centimeters mean 20 millimeters, right? 20 millimeters. 20 millimeters. කොහොමද ගන්නෙ? The value on main scale before vernier scale 0. Before vernier scale 0. What I say? No, you're wrong. Wait. Yeah, your answer is correct, but your final මොකක්ද ඒවා තියෙන එක වැරදි. Very good, Savindya. I got final reading, Savindya. What's final reading? What's the answer? Good, Kalindu. Okay, 20 millimeter is the main scale reading, right? How to get the main scale value before start vernier 0? Before vernier 0. Yes. 20 millimeter is the main scale value, main scale reading. What is the second step? Get coincide parts on vernier scale. Get coincide parts on vernier scale. Get coincide parts on vernier scale. How to get coincide parts? 0, 1, 2, 3, 4, 5 is the coincide value. 5 is the coincide value. Then 5 multiplied by these count. 5 multiplied by discount means 5 into 0.1, 0.5. 0.5 millimeter. Hurry. Now 20 plus 0.5, it is 20.5 millimeter is the answer. Always try to get answer in millimeters. But answers given in centimeters. That's the issue. Answers given in centimeters. Now 20.5 millimeter, how to convert into centimeter? Divide by 10. It is 2.05 centimeters. 2.05 centimeters, not serving the 2.5. 2.05, not now correct. 2.05 centimeters, that means 20.5 millimeter is the reading. If you convert into centimeters, it is 2.05 centimeters. Okay, Yansilu, Vihanga. Please note down them. This is steps on your notebook. Main scale reading, coincide value multiplied by least count, just adding. Main scale and multiplied value adding. It is 20.5 millimeters. 25 millimeters convert into centimeter, is it 2.05 centimeters. තේරුණාද? හරි. Which of the following measurements can be obtained with the help of vernier caliper? With the caliper, right? I think you can remember parts of vernier caliper. The width of an iron rod. Yes or no? Can or can't? The width of an iron rod. Width means just like a thickness, no? Width. Width. What is a part? External jaws. External jaws. Ona මේක ලියා ගන්න. External jaws. External jaws. External jaws. The internal diameter of ball bearing. Internal diameter? Yes. What is a part? Yes. All are correct. Very good. What is a part? Internal diameter. Internal jaws. Internal jaws. Internal jaws. Internal jaws. The depth of a nail hole on an engine? Yes. That's depth measuring strip. Depth measuring strip. Strip. Depth measuring strip. Depth measuring strip. Right. All are okay. All measurements possible to get by vernier caliper. Okay, the vernier caliper is given in which 9 millimeter on main scale divided into 10 vernier divisions. මේ මොකක්ද දීලා තියෙන්නේ? What is this hint? It's, what is this? Least count. What is the least count of this instrument? It is 0.1 millimeter. You should know this. If it is 9 millimeter divided into 10 identical parts in vernier caliper, it is 0.1 millimeter is the least count. Okay, that you found. The position on the scale when the jaws are just touching, sorry, the position of the scale when the jaws are just touching is shown in the figure A. This is a figure A. It's given jaws just touching scale. What is this? Is it measurement or zero error? External jaws touching each other without any object. What is this? It is the zero error measurement, zero error reading, right? Zero error positions. The position of scale while measuring the depth using same vernier caliper is shown in the figure B. Figure B showing the after get measurement using depth measuring strip, using same instrument given in the figure B. I got the question. Could you understand the question first? This is the instrument, zero error, while external jaws touch each other. They are the scale positions, main scale and vernier scale position. Using same instrument, if you got measurement, this is the scale position at this measurement. I got understood. Hari. ඊට පස්සේ අහනවා, according to the given figures, the zero error of the instrument is. The zero error of the instrument is figure A. Now you should know the figure A is given the zero error, right? This is a zero error. This is a zero error. Hari. Now, what is this value? Before get this value, is it positive zero error or negative zero error? Vinuji. Is it positive zero error or negative zero error? Yes, definitely. Others, now we already discussed. It is negative zero error. Why? Why reason? It's negative zero error. Yes, all are correct. It's negative zero error. Why? This vernier scale 0 shift left side than the main scale 0. Shift left side than the main scale 0. I told what is the reason? The wearing off of external jaws. Wearing off වෙලා තියෙන, ගෙවිලා තියෙන. Layers remove වෙලා තියෙන. හරි. Now, what is the zero error value? What's the zero error value? What's the zero error value? What's the negative? Now it is a negative zero error, correct? What is the negative zero error value? Say no. Do you remember? No, Shiva. Small mistake. Do you remember steps of getting negative zero error? No, Hashini. No. No, Savindra wrong. This time you are wrong. Do you remember? I think you can remember how we can identify positive or negative it is simple. If it is shift to right side, vernier 0, shift to right side then mean scale 0, it is positive. Shift to left side then negative mean scale 0, it is negative 0 error. Okay, now you can easily identify. If it is positive 0 error, how to get this positive 0 error value? 0 error value, coincide part multiplied by least count. Coincide part multiplied by least count. But this method not correct for negative 0 error. Savidya. Coincide part multiplied by least count, it's for positive 0 error, it's correct. But for negative 0 error, this is a method. We have equation. Total vernier parts. Please note down with question number. Total vernier parts. Subtract coincide part. Multiplied by least count. This is the equation. Do you remember? Okay, total vernier parts given in the question above. See, 10 vernier scale parts. 10 vernier scale parts. Coincide part you can find by 0, 1, 2, 3, 4 is the coincide part. Right? 4 is a coincide part. Multiplied by least count, I told it is given above 0.1 millimeter. Now, what is the 0 error? 10 minus 4, it is 6. Multiplied by 0.1, 0.6 millimeter is a least count. Not least count, 0 error. 0 error. This is a negative 0 error, 0.6 millimeter, but answers given in centimeters, 0.06 centimeter. Any doubt? Then mataka name. You have to remember it. Now, Savinda, 0.6 millimeter in millimeters. But if it is centimeter, it is 0.06. 10 minus 4 xenon by this equation. Total vernier scale parts 10. It is given above me. 10 vernier scale parts total vernier parts 10 minus coincide part 0, 1, 2, 3, 4 is a coincide value. 10 minus 4. What's the problem? Any doubt, Shivan? You have to remember them, okay? Still only we complete first lesson. Pitam ekka lesson එකයි කරලා තියෙන්නේ. How many lessons? මේ වගේ තව තියෙනවා 24 lessons. Everything you have to remember. Therefore, don't wait until final moment to remember them. The method, always try to remember day-to-day parts. Remember continuously. ඒ කියන්නේ හැමදාම වැඩ කරගෙන යන්න ඕනේ. නැත්තම් මේක very difficult. Not like O level. O level වල නම් අන්තිම මාස දෙකේ වැඩ කළා ඔයාලා හොඳ result අරගෙන තියෙනවා. That's okay. That's possible. But it's not like O level. You have to work continuously and remember that the first lesson completed today. You can't again get first lesson after 5 to 6 lessons completed. Again, you don't have time to come to first lesson. Therefore, now this is a time complete all works and remember all the equations, all definitions. in first lesson, right? This is the time. Okay, what is the correct value of the depth according to the given figure? The correct value is asking, right? The correct value is asking okay, what is this reading? Before calculate correct value, you have to find this reading, depth reading, the instrument given reading. What is the instrument given reading? Yeah, follow previous method. Okay, this is a measurement. කොහොමද කරන්නේ? Get the main scale reading. Okay, what is the main scale reading? It is 4 centimeters. 4 centimeters means 40, 39. This is a vernier scale 0. This is a main scale reading 38 millimeter. 38 millimeter, right? Coincide number 0, 1, 2, 3, 4 is the coincide number. 4 into 0 0.1, 0.4. That means 38.4 millimeter is the final, the instrument given value. Tell me, is it accurate? Is it 38.4 is accurate or not? Asel, is it accurate or not? Yeah, it is not accurate. What's the reason? The instrument has negative 0 error. The instrument has negative 0 error. No, Shiva. Yeah, 3.84 centimeter is a reading. But is it accurate? The question is accurate reading. Is it accurate? Yes, it is not accurate due to negative 0 error. The same instrument එක තමයි මේ ගන්න Shiva. Same instrument. Okay. Now, okay, it has a negative 0 error. Okay, how negative 0 error value 0.6 millimeter. Okay, how we can get accurate value? How to accurate in negative 0 error? Adding, do you remember? Adding, because wearing off is a reason, that means smooth layers removing, then we can get the accurate reading by adding. Okay, 38.4 millimeter plus 0.6 millimeter. Get only millimeters. Then it is 39 millimeters. 39 millimeter is accurate reading. 39 millimeter is accurate reading. Then you can convert into centimeter. It is 3.9 centimeter. Any doubt? Any doubt? No, right? Yeah, the thing is you have to work every day. Every day, at least 1 hour you have to spend, and you have to revise again and again. 0.6 is the negative 0 error. Say no. Previous part answer. This is same question. Same question. Yeah. Yeah, please, if you have any doubt, please ask me, then it is easy to explain. Otherwise, I can complete the paper, but if you can't understand, it's not useless. It's useless. Any other doubts? Savindya? Harid? Vihanga? Hari. Okay, now I can feel something, not everything. Can you explain the question again? Which question, Vinuji? Which part? First one or second one? Both. Hari. I complete vernier caliper, right? Without vernier caliper lesson, you can't understand this. Hari. Okay. Hari. Now the question given, part A describe the zero error and using same instrument after get a depth measurement, its scale positions given in the part figure B, right? Figure A represent the scale position at zero error. Zero error කොහොමද decide කරන්නේ? Jaws touch each other. Those jaws touch each other. Zero error given in the figure A, and the measurement, depth measurement given in the instrument given positions given in the figure B, right? First of all, I got is it positive zero error or negative zero error, right? It is negative zero error. I identified. I have identified it's negative zero error. If it is negative zero error, we have equation how to get the negative zero error. Total vernier parts subtract coincide value multiplied by the least count. This is a negative zero error equation. මතකයිද? හරිද? Now total vernier parts given in the question, it is 10. Total vernier divisions 10, right? 10 minus coincide value 1, 2, 3, 4. 10 minus 4 multiplied by least count 0.1. This is a zero error. The negative zero error. 10 minus 4, it is 6. 6 into 0.1, it is 0.6 millimeters. Convert to centimeters, 0.06. First one, okay. First one, okay. Hurry. Now, this is the measurement, depth measurement using same instrument. Using same instrument means you should know this instrument has error. What is the error? Negative zero error. This value is 0.6 millimeter, right? Then done now. That's already know. Okay, now you can read this measurement. This measurement 38 main scale reading and coincide value 4. Then 38.4 millimeter is a reading. Instrument pen and reading. The instrument given reading. But is it accurate? It is not accurate. Why? The instrument has negative zero error. Then negative zero error, how to accurate? The accurate method is addition. We have to add negative zero error into the instrument given reading. Okay, it is 38.4 millimeter is the reading instrument given. The negative zero error 0.6 millimeter add to the reading. It is 39 millimeter. 39 millimeter convert into centimeter. It is 3.9 centimeter. What's the doubt? Specifically ask if you have any point doubt. Now it is easy to explain. Now, okay, Vinuji. Akhil. Okay. Okay, I just want to show you me kiyange. Now we only completed one lesson, right? This is our first end of our first lesson. Today we can complete first lesson only. But we have another 24 lessons. එකයි complete කරලා තියෙන්නේ. We have 24 more lessons. Okay, therefore, it is not like O level. Again, I repeat this because I think still you didn't identify what's the difference between O level and A level. Okay, in O level you go in classes and coming, and again next week going class and doing work. By this method you can't do A level. Class ගිහින් කරන්න බෑ ඇත්තටම. If you go more than one classes per one subject, you are in the same level. හරිද? ඔයාලා class ගොඩකට ගියත් the same result come. The thing is, every day you have to separate time for your self learn. හරිද? එහෙම නැතුව you are in the same level. Remember, every day at least 1 hour. These days at least 1 hour you have to separate for each subject. For one subject, 1 hour, 1 hour, 1 hour, you have to work continuously every day. Every day you have to practice this. And now this is the end of first lesson, and before next week you have to complete everything. Prepare short notes and මේ වගේ දැන් tutorial එකේ මම දීලා තියෙනවා. Tutorial එකේ මේ difficult points you can mark, difficult points, and you can try again these difficult questions after this discussion. Okay, එහෙම තමා කරන්න ඕනේ. That's a method. Okay, after I think still you are passing enjoy period. After then result anyone, after release result I will conduct a special session how to work for A level. The thing, remember, දැනට මතක තියාගන්න O level විදියට වැඩ කරලා කරන්න බෑ. Okay. Yeah, I think I can understand your situation. Still you can't understand what's the difference නේද? ඒ කියන්නේ ඔයාලට තාම තේරෙන්නේ නැහැ මේක කොච්චර difficult. Still only we discuss one lesson. Okay, after ටික දවසක් යද්දි මේක pattern එකට එනවා. It's okay, but you have to come to the pattern as soon as possible. That's the thing. Anyone not in the pattern state. තාම කවුරුත් ඒ rhythm එකේ නැහැ. හරි. In a micrometer screw gauge, when circular scale moves 5 millimeter along the linear scale, 5 millimeter along the linear scale, sleeve in 5. When circular scale moves 5 millimeter along the linear scale, sleeve in 5 revolutions. ඒක අනිත් පැත්තට දීලා තියෙන්නේ නේද? With the actual meaning is when rotate circular scale 5 revolutions, the along linear scale, circular scale moving distance 5 millimeters loop, right? What is the screw gap of the instrument? Do we remember what is the screw gap of micrometer screw gauge? The definition I have given in the tune. The definition of the micrometer screw gauge. No. I want the definition of screw gap of micrometer screw gauge. What's a screw gap? While rotate circular scale one complete revolution. In a one complete revolution of circular scale along linear scale, it's linear moving distance, right? Okay, I'll show you. I think you can remember that. This is screw gap. This is screw gap. Okay, this is screw gap. Now you can see, yeah, circular scale 0 and linear scale middle axis coincide. And if I rotate one complete revolution, now linear scale value 0, right? 0 with if I rotate one complete revolution like this, one complete revolution until coincide 0 along linear scale, the circular scale moving distance, this point to this point. Okay, this distance is a screw gap, right? This distance is a screw gap. Understood? Within one complete revolution, the moving distance is the screw gap. It is given in the circular scale move 5 millimeter length within 5 revolution. Then what is the screw gap? What is the screw gap? What is the answer for this question? Yes, very good. Very good. No, say no. No. The question asks, this instrument within 5 revolution rotate the moving distance 5 millimeter. Then what is within the screw gap mean within one revolution, one complete revolution along linear scale, circular scale moving distance, it is 1 millimeter. Why? Within 5 revolution, the moving distance 5 millimeter. Then the screw gap means within one revolution. To get one revolution, you have to divide by 5. Yes. I got say no. 5 revolutions rotate with the 5 millimeters. Then one revolution, only 1 millimeter. Understood? Yes. Very simple question. The scale of micrometer screw gauge of pitch P, pitch means screw gap, right? Pitch screw gap P is divided into n number of equal circular segment. Which of the following is the least count that can be measured with this instrument? Okay, the least count of micrometer screw gauge, the least count of micrometer screw gauge, the least count of vernier caliper, we have equation MSD minus VSD. Same D, same, very good Shivan. Same, we have equation for least count of micrometer screw gauge as well. Least count of micrometer screw gauge. The least count of micrometer screw gauge. What is it? What is the equation? I have given it to you. Pitch over screw gap or pitch. What's the meaning of pitch? Within one revolution moving distance. Within one revolution moving distance. Pitch divided by number of circular scale distance. Number of circular scale divisions. Number of circular scale divisions. Okay, screw gap. Yes, to gap of pitch it is given as P and number of circular scale divisions N, right? P over N is the answer. P over N. Remember equations? Mathagati end over. P over N. P over N. Hari. Avulak naha me first paper එක නිසා. Remember this all equations and all definitions given in the tute for each lesson you have to remember. මතක තියාගන්නම වෙනවා. හරිද? Therefore හරි මේක අපි ටිකක් දුර යද්දී ඔයාලට තේරෙයි. ඔයාලට තාම තේරෙන්නේ නැහැ ඒක. Okay. Which part of micrometer screw gauge should be rotated to be prevent unnecessary pressure being applied to the object while measure. Okay, what's the part? Which part? කොහෙන්ද අපි rotate කරන්න ඕන to prevent unnecessary tightness? Yes, very good. Thimble head or ratchet. Ratchet or thimble head. Very good. Ratchet or thimble head. Okay, that we already discussed. The reading shown on the micrometer screw gauge shown in the figure. Make reading එක. We discussed many questions. What is this reading? What is this reading? Okay, I explained step-by-step method to read this type value, no? Read this type measurement. Step-by-step method. Vinuji, no. You are not correct. Your linear scale value has error. No. Xenon, no. You are wrong. No, Shiva. Okay, I think you can see these lines. Make them andinam. One. Check now. No, Hashim. Check again. Okay, what are the steps? No, Vinuji. Small mistake. Very small mistake. Now correct, Shiva. Now correct. Now correct. Say no. That's why you have to careful. Okay. What are the steps? Get the linear scale reading first. Now correct. Get the linear scale reading. Vinuji correct. Okay, what is the linear scale reading? It is 0, 1, sorry, 0 0.5, 1, 1.5, 2, 2.5, 3. 3.5 is the linear scale reading. 3.5 millimeter is a linear scale reading. Second step, lines were not clear. Good. Second step, get the coincide number, same as vernier caliper. Vernier එක තමයි අමතක වෙලා තියෙන්නේ නේද? ඒක තමයි. You have to revise again හැමදාම බලන්න ඕන. හැමදාම කියන්නේ පුළුවන් වෙනකම්. Okay, this 45, 46, 47, 48 is a coincide value. 48 is a coincide value. 48 multiplied by least count, 0.01 millimeter. Now 3.5 plus 0.48 millimeter. Give me a second. Sorry. Yeah, now correct, Hashini. Now correct. Okay, it's 3.5 plus 0.48, 3.5 plus 4, 8 millimeter. 3.98 millimeter. 3.98 millimeter. 3.98 millimeter. Answer number 3. Answer number 3. Okay, the circular scale of micrometer screw gauge consists of 50 divisions. 50 divisions. The least count of the device is 0.01 millimeter. The pitch of this device will be. What's the pitch? Pitch means screw gap. While rotate one complete revolution, the moving distance. The moving distance, the linear moving distance. Come with the gun. What is the equation? What's the equation? The least count equal pitch over number of circular scale part. Pitch over number of circular scale parts. That's the equation, basic equation. Oh, sorry. Number of circular scale parts. Right? Okay, the least count equal pitch. The least count is already given 0.01 millimeter. 0.01 millimeter. What's the pitch? P කියලා දාගමු. Pitch. Number of circular scale parts 50. 50. Now P equal, how to isolate P? Cross multiplication. 50 multiplied by 0.01. 50 multiplied by 0.01, what is the answer? 0.5 millimeter. Good. 0.5 millimeter. This is the pitch. This is a pitch. 0.5 millimeter, answer number 3. Answer number 3. Right? Very simple. Final page. Hi. Part of micrometer screw gauge when anvil and spindle in contact is shown in the diagram. In contact. Then what is this? This is a zero error, right? In contact is given in the diagram. What is the correct statement about the instrument? Okay, my first question, what is the type of this zero error? Is it positive zero error or negative zero error? It is positive zero error or negative zero error? Positive zero error or negative zero error? Yes, it is negative zero error. How to identify? The circular scale zero passing away, may vadipura, over rotate. Over rotate. If it is correct, this is the position that you need to stop. But it is additional rotate, over rotate due to wearing off. This is negative zero error. Good. Okay. How to get negative zero error value? How to get negative zero error value? අපි negative zero value එක ගන්න කොහොමද? Same method as vernier caliper. මතකයිද? In vernier caliper negative zero error, total vernier parts minus coincide value multiplied by least count. In micrometer screw gauge, no, I want negative zero error value, Vinuji. Just negative zero error value. Negative zero error value, total circular scale part 50, minus coincide part, coincide 45, 46, 47, multiplied by least count 0.01. Matakai. Say on. Remember, 50 minus 47, it is 3. 3 into 0.01, 0.03 is a negative zero error. It's a negative zero error, therefore we can add an accurate, right? Then answer should be the zero error wrong. The zero error 0.43 error. The zero error 0.03 correct, which should be added to the final reading. Yes, answer number 3. Understood? Any doubt? Any doubt? Vinuji and Sweta, Savindya. Okay, same type question again about vernier caliper. The figure shows the position of the scale when the jaws of vernier caliper are in contact. The correct statement about this instrument. Okay, what is this type of zero error? It is in contact. Jaws are contact. Then what is a? It is zero error. What is the type? Negative or positive? Say not. Savindya. Good. It is negative zero error. Then how to get the negative zero error value? Total vernier parts 10. Total vernier parts 10. Get the coincide value 0, 1, 2, 3, 4, 5, 6 is a coincide value. Then 10 minus 4 multiplied by least count 0.1. 6 into 0.1, 0.6 millimeter is the least count. Then 0.6 millimeter is the zero error. It's a negative zero error. How to accurate? By adding. 0.6 millimeter zero error to be adding. No, sorry. Coincide value 6, no? Coincide value 6. Then 10 minus 6, 4. 4 into 0.1, 0.4. Answer number 3. Clear? Any doubt? Okay, final 2 questions we have. Asel? Understood? Akil? Okay, you have to go through again this paper. The following are facts about triple beam balance. Triple beam balance we discussed last week. The maximum reading up to 610 can be obtained. Okay, it is optional, no? Maximum reading without extra bar 610 correct. But with extra bar it is 2610, right? Therefore, it is optional. We can consider later. The maximum sensitivity, that means least count 0.1 gram, it's correct. 0.1 gram. The principle of moment of force. Moment of force means the lever mechanism. The lever mechanism, that's correct. The correct statements about the triple beam balance is no answer A, B, C. Therefore, B and C. B and C. That's why I told part A, it's optional. If without extra bar, it's correct. With extra bar, it is 2610. Right? Final question. I need the answer for final question from you. Which of the following reading is a measurement taken with a standard micrometer screw gauge? Standard micrometer screw gauge. Okay, let's see one by one. 3.4, is it okay or not? Please send me. 3.4, is it okay or not? By standard micrometer screw gauge. පුළුවන් ද බැරිද? Yes, no issue. Right? 3.40. 1.52, yes or no? 1.52, yes or no? 1.52, yes, no doubt. 2.03 centimeter. That means 20.3 millimeter. No? Yes or no? 20.3 millimeter. Yes, no doubt. No problem. 3.31 centimeter. 3.31 centimeter. 3131 centimeter means 33.1 millimeter. Yes or no? What do you think, Savindya? Final one. Standard micrometer screw gauge asked. Actually, it is impossible. What is the reason? What is the reason? I Barry. Do you remember what is the linear scale total length of micrometer screw gauge? Standard one. It is 25 millimeters. Remember, standard micrometer screw gauge maximum reading 25 millimeters. 25 millimeters means 2.5 centimeters. Can we get 3.31 centimeter? No. Matakai. Say no. $25 millimeter is the linear scale maximum length. Standard one. Then we can't get 3.1. 3 point values. More than 2.5 we can't get by micrometer screw gauge. In vernier caliper, what is the maximum? 15 centimeters. 15 centimeter means 150 centimeters, right? I think you can remember. Okay. D, impossible. A, B, and C only. Answer number 3. A, B, and C only. Okay, that's the end of MCQ part. You have a homework. You have a homework, 1 page. It's a structured part. You have a small homework. And this is the end of our first lesson, measurement lesson. After complete this homework, this is the end of measurement lesson. Next week, you have an exam. You have very small exam with only 20 MCQ questions. You have only 20 MCQ. මේ අද තිබ්බ වගේම MCQ 20ක් විතරයි තියෙන්නේ. It's online exam. I'll guide you what are guidance and I will give you all information next week. Okay, you have ready. I will send the paper structure and everything into our community, WhatsApp community. Okay, if you have any doubt in lesson number 1, now you can ask. No, right? Okay, then let's meet next Sunday with the exam and we are going to start new lesson as well. New lesson, our second lesson. Okay, goodbye.